Hello again, welcome back to the garage. Not the most salubrious of environments, but it's all I've got at the moment. I said that we'd have to reach a point where we talk about something very specific in relativity theory. And the reason for this is we began by saying that in questioning assumptions we took an example, the principles of gravity, and of course they ultimately come to relativity theory, and in particular general relativity. Now that might be a bit off-putting to a lot of people, but in actual fact it is a largely philosophical work. And general relativity focuses, or at least the heart of general relativity is the principle of local equivalence, which states that the effects of gravity on a local level are equivalent to the effects of acceleration. It's a little bit like saying when you're sitting in a train and it takes off, you get a thrust backwards, and that backward acceleration, or that backward feeling, is equivalent to the feeling of going up in a lift. So that acceleration and gravity have a very similar effect. Now, Einstein, I don't know how he did it, it's almost like that was his genius. He would come up with the right examples to illustrate things, and yet at the same time somehow he would meddle with them. I know that sounds a little bit like blasphemy these days, since science is almost like a religion, but this is how it goes. If you listen to anybody who talks about this principle, they will talk about rocket ships and how if one starts to accelerate, it's the equivalent to one near a planet being dragged down towards it, and the feeling that it gives to the person inside. Well, this is how everybody that writes popular science more or less discusses local equivalence. But Einstein actually said something else. Because when he describes his lift, first of all he puts it into an arena where there's no gravity, as if there were such a place. But anyway, we'll forget that part. But he puts a hook on the lift, and then he says, to this hook is attached a rope which is being pulled by a being who is immaterial to us. Well, actually, the reason the being is immaterial is because he wants you to look at what's going on inside the lift, not what's going on outside. Now, what difference does this make? Well, it means that you're kind of emphasizing the experimental method, which is virtually in a box. You're assuming nothing, so you're locked in this box. And if you, whatever experiment you perform in this box is what you will use to say something about the reality that's outside the box, which sounds very much like Plato's cave in many ways. But anyway, here's the thing. If you involve the accelerator in the description, then if you're in the lift and you drop something, the whole lift will experience an increased acceleration because the object dropped will no longer be part of the system. So you could say that, I must be accelerating. Yes, but the same thing would happen if you were in a lift suspended above the earth on a spring. If you dropped something, then you would feel an upward force. So in a way, you can say that whether you incorporate the accelerator or not, the effect is the same. Well, actually that's not quite true. Because now assume that you're not looking at it from the point of view of an experiment going on inside the box. In fact, you don't perform any experiment at all. Then there is another conclusion that you can come to, and it's this. If you're in a box and it accelerates, that little bit of acceleration would be equivalent to the addition of a great deal of mass to the planet or the body above which the lift is suspended. Now look at the difference. A little bit of change in one lift is equivalent to a great deal of mass being added to the planet in the other. Which means that, in a way, the first lift shrinks down into something very tiny, and it's equivalent to this big lift suspended above a bigger planet. So that a small amount of change is equivalent to a great deal of mass. Now, when you consider that quantum gravity is about the desire to find some kind of link between the very small and the very large, well, actually, if you can free your mind from the experimental method that locks you in a box, suddenly it opens up. Because this addition of mass means that big changes occur from the small to the large. So in a way, quantum gravity is another word for holism, except it cuts out all reference to desire. It keeps it cold, it keeps it ideal and forced upon things. That is, the things that are changing are not in themselves actually affecting the changes occurring to them. And that takes us back to Sartre, if you remember, who said there can be nothing more absurd than the notion of something self-activated based on inertia. And yet that is the very absurdity that we're looking at. And the irony is that that's the very thing, that quantum gravity relation of the very small to the very large is what was thrown out of the window in order to establish science, which was the Hermetic method of seeing how things above are reflected in things below. And in order to get a fuller picture of that, you actually need to involve desire, which we have not yet even discussed. So in a way, what we're finding in science is a constant maintenance of space-time, i.e., things dead. When the macro-micro reflection worked simply because in that way of thinking, everything is alive. So the real problems that we face now are not how are we going to unite all the forces. It actually boils down to, what does it mean to be alive? What does it mean to desire? Because the human being contains, almost like that microcosm, all those things that make up the rest of the universe, however large, however small. But we no longer have a method for exploring that idea. And there's enough to think about there for the time being. So we'll leave it there for now. Cheers.